So we've done a lot of talking about gases. And what we learned about gases is that there's a lot of space between the particles, and they're really not interacting with each other at all. That's not the case with liquids and solids. We say that liquids and solids are touchingly close. So they're close together. Velcro doesn't work at large distances, does it? You have to be like touching for the Velcro to hook up. So in liquids and solids, these intermolecular forces are going to have an impact. What's different between liquids and solids is that in liquids, the atoms or molecules are still able to move relative to each other, whereas in a solid, they're stuck in place. Okay? So you're sitting here as a solid, except that one's melting. She's melting and going out the door. But the rest of you, okay, now, you guys are solids, right? And so the person who's sitting to your right has been sitting to your right most of the class period. We're not moving relative to each other. But in lab, you're moving around, right? That's a liquid. Because those forces are not as strong. They're strong enough that they're not flying apart from each other, but they're just kind of squeezing past each other. So here we have illustrations. Here's the gas, lots of space between the particles, no interactions. Here's a liquid, touchingly close, but moving around. And then in a solid, the particles are fixed in rigid positions. They are still moving, but they're just vibrating. Any questions?
So it's like gas is more of like outside, liquids like lab, and solids like...
Yes, exactly. The gas is like students after class is over and you guys go out and you go your separate ways, right? You don't interact very much necessarily. A liquid is like in lab. We're in a confined space. We're close together, moving around. And then a solid is like lecture, where you're all sitting still in chairs. Okay, but you're still breathing. So I'm going to go over this part pretty quickly. Properties of gases. They have low densities compared to liquids and solids because of all the empty space between the particles. They have indefinite shape. They take on the shape of their container. They also have indefinite volume. You can change the volume of a gas very easily. Just change the size of the container. They have weak intermolecular forces. Those molecules do run into each other, like carbon dioxide. Carbon dioxide molecules are going to run into each other, but the intermolecular forces are very weak compared to the kinetic energy that they have. And so when they run into each other, they just bounce off. For liquids, liquids have high densities in comparison to gases. They also have indefinite shape. They take on the shape of their container, but they have definite volume. They are not easily compressed. The volume of a liquid will stay the same regardless of the shape of the container that you put it into or the size. So they have moderate intermolecular forces. The forces are strong enough relative to the thermal energy that the particles can't just fly away from each other. They're held together. They're attracted to each other, but there's enough thermal energy that they can slide past each other. In a solid also has high density compared to a gas. Liquids and solids, their densities can vary a bit. Not all solids are more dense than liquids, but they are both more dense, much more dense than gases. Solids have definite shape. They don't change shape when you put them in a different container. Think about an ice cube. Take an ice cube out of the tray and put it in a bowl, and then you drop it into a teacup. Does the shape of the ice cube change? No, it just sits there. It's got the same shape. Its volume doesn't change either. Solids are not easily compressed. And here we're not talking about things like sponges. We're talking about solid stuff. Solids can be crystalline. Those particles can have order, or they can be amorphous, A meaning without, morph referring to shape, so disordered. They have strong intermolecular forces relative to the thermal energy. So they are held together strongly enough that they can't slide past each other. An example would be sugar. So liquids take on the shape of their container because they can slide around. Solids do not take on the shape because their forces are stronger between the molecules and they're fixed in place, but they are vibrating. So if we look at the particles inside this iceberg, these particles are vibrating in place, but they're not moving relative to each other.